radical axis of two circles. The radical axis of two circles is the locus of a point, powers of which with respect to the two circles are equal. So basically you have two circles, right? You have two circles and there is a point whose power, the power of this point and the power of this point is equal. Similarly, since it says locus of a point, that means there is a whole set of points, and if we connect these points we would get a line. So let's figure out analytically. So let's say S1 is x square plus y square plus 2g1x plus 2fy1, no, 2f1y, f1y plus c1 equal to 0. Remember, between two circles the only thing that would be different is g, f and c. So x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Now power of px1y1, let's say this is p x1 y1 with respect to s1 and s2 are equal by definition. Here we have to substitute the x and y with x1 y1. So x1 square plus y1 square plus 2g1x1 plus 2f1y1 plus c1 is equal to, again, square root x1 square plus y1 square plus 2g2x1 plus 2f2y1 plus c2. So now this square root gets cancelled. Okay, x1 square y1 square y1 square. So we are left with 2g1x plus 2f1y1 x1 c1 is equal to 2g2x1 plus 2f2y1 plus c2. Okay, so let's bring it to this side. So 2g1 minus g2 x1 plus 2 f1 minus f2 y1 plus c1 minus c2 equal to 0. Now here this is a linear equation in x and y, right? So linear equation in x and y, or rather in this particular case x1 y1. So therefore a straight line, and this is the equation of the radical axis or locus of the x1 y1. Okay, now let's look at one or two points. Radical axis of two circles is going to be perpendicular to the line joining the centers of the circles. Let's see. Again, let's say S1 and S2. S1 is x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. And S2 is x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. And the center of S1 is A minus g1 comma minus f1, and similarly of s2 is, let's say, b minus g2 comma minus f2. Now the slope of AB would be what? Slope of AB would be minus f minus f1, sorry, f2, minus f2 minus f1 divided by minus g2 minus g1. So this would be minus f2 plus f1 by minus g2 plus g1, or we can write it as f1 minus f2 by g1 minus g2. So radical axis is 1 minus g2 x plus 2 f1 minus f2 y plus c1 minus c2 equal to 0. Now let's rearrange it. So minus 2 g1 minus g2 x by 2 f1 minus f2, and before that we would have taken c1 minus c2 to the other side, c1 minus c2. So here it is in the form of y is equal to mx plus c. So the slope is this. The slope of the radical axis would be 2 gets cancelled, and we are left with this g1 minus g2 divided by f1 minus f2. Now let's say this is m2, and let us say this is m1. So we know when are two lines perpendicular to each other? When the product of their slopes is minus 1. So f1 minus f2 by g1 minus g2 minus g1 minus g2 by f1 minus f2, and here this and this gets cancelled, this and this gets cancelled, only thing that is left is minus 1. So the product of the slopes of the line joining the two circles, centers of the circles, and the slope of the radical axis is minus 1. So therefore they are perpendicular to each other. So therefore a radical axis is perpendicular to the line joining the centers of the circles. So if we have to see this diagrammatically, let's go back here. If we connect these two, then this would be 90 degrees. Okay, very interesting. I think that's enough. Bye for now.